Hello, everyone, and welcome to my session around two brand new features that we will ship with the upcoming December release, which is Flowable service level agreements and analytics in the context of high-scale work management. That's what we're going to look into in today's session. Let me quickly share the agenda, what's in it for you in this session. So first, I'm going to use a bit of definition. What is service level agreement management and why should we even care? And of course, it's all around high scale. What does it mean if we have a lot of work that you have to cover with service level agreement? You have a lot of people working on it. How does that work and how is Flowable supporting it? And then we deep dive into the Flowable service level agreement model that was that is coming in Flowable design and the runtime as well. And of course, we're looking into a practical example with a demo, how that looks like, how you can define those SLAs, how they behave at the runtime, and what you can do with it. So without further ado, let's dive into it. Why should we even care about service level agreements and what are they? So typically service level agreements come into play when you talk about or when you attach whatever you do as a business to a contract. Let's say you're working a support desk, a help desk, whatever it is, and you guarantee your customers a certain response time, a certain resolution time. Or your service that you run or your software you run as a service has a certain uptime you don't want to miss and things like that. Sometimes they are even attached to penalties, which means you have to pay back your customer if you miss those deadlines. Or it could even get worse. If you look at a law firm, they typically have hard deadlines, maybe given by the court. They have to file in some evidence, some information, some documentation before the deadline. Otherwise, they might even lose the right to present in court or be able to object in court. So those are really hard deadlines you definitely don't want to miss. So how does a service level agreement look like in an example of a support organization? I took a lot of information from our own Flowable support organization to give you a bit of inside view what a service level agreement. So for instance, severity 1 in our definition means the production system is down, you can't work anymore, which is a pretty big incident, right? Or severity 2, some parts might be affected, but you can still work up to or down to severity 4. There's low or even no impact. Maybe there's even a request for a change or something you wanna track and file on a support organization. Let's look on a timeline how that works. So for instance, when we talk about the severity 1 issue, like production system is down, at some point in time, the system goes down for whatever reason. It typically takes some time until it is detected, right? And then you need some time to actually report it. Maybe you need to take some screenshots or some log files or whatever, and then you report and file the incident to the support organization. And that's where all the stuff around tracking actually starts. As soon as the issue is known at the support organization, then all the tracking, all the timing actually starts. And then we know several things around moving forward in time. Like you typically have what we call the initial response time or reaction time. That is also part of the SLA. It's a guaranteed time that you respond to such an issue. And then you probably need some more time for actual analysis. What's going on? Can we propose any type of workaround, or maybe we need some more information from the customer? That's what we call the intervention time. And then you typically take some more time until you can deliver a workaround to your customer, which is called the correction time. And eventually, maybe you cannot fix the bug right away, but you find a workaround how to fix the issue so production gets started again. And then the final resolution time typically is when you develop and deliver a bug fix to the actual issue. And then typically customer has to test it, to put it into production. And then finally system is up and working again. So that's a typical way on how to look into the timing of an SLA-backed work item. Now, when we talk about severity levels, we also talk about different response times, typically, or resolution times. So, for instance, you might even have different levels of SLAs, typically attached to a different price. So, for instance, for a platinum SLA that has 24/7 coverage and super fast response and reaction times, then you typically pay more as a customer, as if you say, no, Monday through Friday, 8 to 6, that's fine for me. 6 hours, if I have a system down issue, is good enough. So you can pick and choose between the SLA level, response times that are attached to it, and of course, the price tag. Now, how does that translate into high scale? If we look at those kinds of issues, if an issue is filed, we know, okay, we have to react within 4 hours, 6 hours, whatever the SLA defines. But what happens if that goes into a big scale? What happens if we have hundreds or thousands of items being filed? Some might be more urgent as others, and we definitely don't want to lose track of them from a timing point of view. You might have to pay penalties, or as we saw before, you might even lose some right in court if you miss those deadlines. So you want to make sure that you don't miss anything. So at a certain number of scale, you lose the ability to do that manually. Maybe an Excel file, some timers or whatever doesn't cut it. You need something which is way more system related and actually tracks stuff behind the scenes. So the goal obviously is do not miss any of the deadlines. That also involves prioritization. So maybe just keeping track of all the timing isn't enough. Maybe you have to reprioritize. If a severity 1 issue comes in, maybe you have to stop working on the current severity 2 one because the other one actually is more important to solve. Things like that. And it can become quite complex the more and more workload you have. So you definitely need something like an SLA management system behind the scenes, helping you to prioritize, helping you to keep all the timing in sight. So an SLA-based system can also collect a lot of data and provide inside information, what's going on in your organization, learn from the past, or even predict the future, and see how to prioritize or making your overall SLA or breaches better for the future. So that's where analytics, real-time dashboards and metrics come into play. We will cover those in the live demo as well, what Flowable brings in that area. But the cool thing is we can also use that data and kind of feed it into predictive AI. There's another talk, I think it's probably right after this one, where Joram and Valentin also talk about predictive AI. What can we do by feeding a lot of data into an AI machine learning kind of system to do stuff and analysis for us. And if we do that, we can also predict the present and the future. Maybe we can look at the data that we covered into seasonality, or we know there's something going to happen, and it can tell us how much workforce we need, how many people we need to not breach the SLA for the upcoming workload that goes into the system. Again, the goal is to stay within SLA and not breach it at all. Now, with that being said, let's dive into the Flowable service level agreement model that is going to be shipped with the December release later this year. Now, we have an all new model type in Flowable design, which is called SLA. So you can create as many SLAs as you want. And we will quickly look into that directly in Flowable design just in a minute. And of course, those models, you don't want to define all those timing issues within every single task you want to be monitored, or a case or process, whatever it is, by such a model. So you want to reference those, create those models once and reference and use them as many times as you want or need. So in Flowable, you will be able to reference those SLA models from within a task, case model, process model, and even on a stage to cover the start and end time of those work items by an SLA. The tracking actually happens in real time. We are making use of the timer job infrastructure that we already have in place for a long time to basically track the SLAs. But the cool thing is, it's not only tracking the due times, it's also giving you the ability to define times that something needs to happen, like a notification. You don't want to be notified if the due time is already up and passed and you're overdue and you breached the SLA. You probably want to have a notification up front, like, I don't know, depending on the SLA, 30 minutes before due time, you want to get a notification. Or 20 minutes before, you want to start an escalation path, or even reassign an item automatically to somebody else because the current assignee might be busy doing something else, whatever it is, right? So we will look into how you can actually create those type of what we call escalation steps on a timeline to cover all the tracking going on behind the scenes. And of course, we also create analytical data behind the scenes. We store it as part of the history, of the Flowable history. And all those information that we capture at runtime, whether due time was met or breached, whatever, all those really valuable information is stored in the history. So we can use it for analytics, we can use it for real-time dashboards, and we can use it to feed into predictive AI to cover stuff like, show me the necessary workforce for tomorrow that I need to bring on place to solve all my issues. And then, of course, we have some interactive dashboard components. I'm also going to cover those in the demo that give you a good real-time overview into your SLA management. Am I currently on track? Am I breaching something? Do I need to care? And things like that. Now, let's get started on the Flowable SLA model. And for that, I think the best way to actually show it is to look into Flowable design. So I have a new app here, and I'm going to walk through an existing, just a very simple, basic service level agreement model that I created up front, and walk through the different parts that we can do and use in that model. So first of all, we can select what is the business, we call it the business calendar. You can work 24/7, or you can say, no, I want to work on a standard business calendar. Well, maybe you ask, well, I'm not working 8 to 5, I'm working 8 to 7, 8 to 8, whatever. And in a future release, we will also be able to let you define your business calendar precisely yourself. So you can say, I'm working from 8 to 12, from 1 to 5, from Monday through Friday, or Friday only to 4, whatever it is. You will be able to come up with your business calendar totally yourself. You can even add vacation days, public holidays, things like that, which of course we need to keep in mind when calculating due times and work backwards in that regard. Now you can define or choose between what we call reaction and completion time. If we remember the first time line that I provided, some SLAs actually have two due times that are covered, like in what time do I need to react, kind of pick up the issue and work on it, and until which time do I need to build a solution or to complete it, basically. So you can choose between only completion time, only reaction time, or even both. In my sample, I use a completion time of 4 hours, and I have to react and basically pick up the work on the work item within 2 hours. Now, when we create such a work item which has an attached SLA, we also initialize it. There's also a section which we call initialization that gives you the ability to initialize that work item. For instance, you can say, in my case here, I'm setting the priority to 50. So if I use that SLA in a task, I can initialize the priority on that task to 50, where I could say, no, it's more important than 50. I'm going to put it to 60, whatever it is. You can also use a lot of actions. We'll cover those in a second, like change assignment. You could do something like the routing service and say, I want to do a round robin across the currently available people, my staff, and just distribute the tasks accordingly. Or you could do really crazy stuff according to skills. We have customers using different skills of their employees. So work according to complexity get distributed according to the employees having different skills. Or you can even send a notification. So there's a lot of action types we support: changing priority, assignment, do some load balancing, whatever. And then, for instance, set or change a variable, send them a message into Flowable Engage. That even includes WhatsApp, WeChat, Line, those kind of channels, or send an email. So that's initialization. That happens exactly when the work item gets created. Now, the interesting piece is escalation. What happens as we approach those deadlines? As I mentioned before, we cannot only track the due time itself and say, hey, you're overdue. It's too late, maybe. We want to do stuff before, right? So you can add as many steps as you want. We call them escalation steps. So for instance, I have 4 steps here. And for each one of the steps, you can define the timing. So you can say, I want to execute that set 30 minutes before reaction time. Or you could say 30 minutes before completion time. And then, of course, you can choose whether it's hours, days, seconds, minute. Seconds probably is super cool for demos, like we see later. And then again, the same actions as before. You can say, I want to change the priority and increase the priority. The closer I'm reaching my deadline, I want to increase the priority. So maybe in my dashboard, which is ordered around priority or due time, it goes up. That item goes up as it's not handled properly. Or I want to reassign. Maybe that person which is originally assigned to the item is sick or whatever. I want to reassign to somebody else at a certain time. Or I can even execute a full-blown escalation process that takes care of escalating that work item. And again, of course, sending conversational messages, emails, things like that. And here, as an example, I use 30 minutes before reaction time, 10 minutes before reaction time, I send a notification. 30 minutes before the completion time, so the second due time, I increase priority again, and even 10 minutes before, I send another notification message that somebody really needs to pick up the work. So the idea is to not only keep track of timing, but also be able to escalate properly should I miss one of those times, even before the actual deadline. So I can still be on time if I pick up the work. The last section we support is what we call suspension. So we also allow you to suspend work. Maybe your inbox is flooded. You have tons of work. You need to keep track on the right priorities. So what we allow you to do is define on the SLA model as well, because it's related to service level, of course, who is able to suspend. Maybe the current assignee is able to suspend as well as the owner, kind of like the creator of the work item. And of course, it depends how much am I able to suspend, because suspension means those work items might even be hidden in your dashboards, in your work inboxes, to focus on the real important ones, right? And then you can also define, I cannot suspend any time longer than 30 minutes before completion time, for instance. Or you can also define it in relation to reaction time and so on. So those basically is the full SLA model that is new in Flowable design. Now let's go back to the slides here. So when we look at those escalation steps a bit on a graphical way, on a timeline, let's look at the timeline again. So when we start a work item which has an attached SLA model, that's where all the initialization happens, like we saw in the initialization phase. Like priorities being set, assignee of the work item is set. And then that's where the whole tracking actually starts. Now, we have one or two due times that we can track. So reaction time and completion time. And then we work backwards, or depending whether you say that my timing is something like 10 minutes before or after one of those reaction or completion time, you can define those timing issues where something happens. We call them escalation steps, like sending a message, reassigning the work item, increasing the priority, whatever it is. And eventually that results in a timing that those escalation steps are being fired and executed should you not react before time. So if we look at escalation step 1, it means if we're moving towards in the time and we did not yet react on the work item and we pass that time, that step will be fired. Let's move on. And now we're picking up the work. So reaction is done, which then kills the second timing because we have done our work, right? So for all those escalation steps, we keep track of timing and we reach the reaction time accordingly. Those are not executed. So really giving you all the reaction needed at the proper time. Now we want to look at a practical example. How does that look like in a real world example? I didn't want to go into something like IT support management. That's a bit too boring. So I picked up the sample of a laboratory services. I called it MedScience Lab Incorporated. Sounds pretty cool. And it's obviously fully digitalized. So which means we have fully automatic sample testing end to end. And of course, whatever I tell you now, I have talked to real people that I don't tell something which is not, that's actually possible nowadays. And of course, we have a tightly managed service level agreement, which means depending on the analysis that we have to do, those samples might take 4 hours, 2 days, 1 day, whatever it is. And we want to keep track of those. Not everything can be automatic, of course. They're semi-automatic. So you need to prepare the sample before they are fed into a machine that does the analysis. Some are even as complex as you have to do the analysis totally manually. And that obviously takes up more time. And of course, we also want to serve a customer portal so they can pre-submit samples, and then they're going to be picked up and brought to the laboratory where they are going to be worked on. And of course, we want to make use of all that information that we were talking about, like the past, all the information that we have in the past and the present, even with the pre-recording of samples, we get kind of like a head start. Oh, we are awaiting like a lot of more samples today than we had yesterday. So maybe we have to prepare ourselves and reprioritize or even increase the workforce that can tackle those analyses. Now, let me switch to demo again. This time, we will also cover some parts of the actual models that we did to create the demo. But let's go first into Flowable Work, our runtime, where that lab, all that processes, cases actually run. I have 3 different dashboards. So I have one which is showing my current workload, all the currently samples that are being worked on. And I also see some color codes. I prepared a couple of data. So we have a bit of data that we can color code. So yellow means we have missed the reaction time, which in our case maps to when we start and do the actual analysis after preparation. And red means we have breached the full SLA by not completing the analysis in time. So yellow is not as bad because it's still happening in the laboratory. But if we are starting too late, then we will most likely not reach the full SLA for completion of the analysis. That's why we also want to know upfront. That's why we use reaction time when we start analysis and the completion time when the full analysis should be done. We have 2 SLAs, and a 4-hour SLA and a 2 days SLA, just not to get too complex now. And we also have a Third, dashboard, which takes us to master data management. Now, the cool thing is, whatever you see in the demo here was built with flowable models only, no single line of code. I make use of data objects that we have already quite some time now for handling my master data, like my customers. I have two doctors, Dr. Strange, and some other in a company called MedDoctors, a couple of doctors. And obviously, I want to make them a good usability. So whenever they record a sample for one of their patients, I collect that data. So the next time they add another sample, they don't have to fill out all the details again. And of course, that also works through an API. So we could do a full-fledged integration so they don't have to type in data because they most likely have that data in their system as well. And then most importantly, I have the list of analyses that I provide in my laboratory. I just added a couple of those. Those are actual analyses, by the way. And we also have some details like the typical code for such an analysis. What's the name? What's the material? What do I need to be filed for the sample so I can do the analysis, like blood serum, for instance? What's the method for analysis? And also some more information for the analysis in the laboratory or the doctors so they can get some more information. So all that is stored as data objects in Flowable and can be easily used, as we will just see in a minute, by both my laboratory, but also by my customers, the doctors. All right, now the third one is my laboratory, my kind of portal that I can offer my customers. This can easily be embedded into my website, so the doctors could log in and then basically see an overview of their own samples, their own patients, and all the information in real time, which is really nice. Nowadays, typically, you don't know what's going on with your samples. Once you file them, of course, they tell you maybe within the business day, you should get the analysis, but you don't know when that's going to happen. Now with Flowable, you could make that real time. As a doctor, I can see all my filed samples. I can see the current state. For instance, here, analysis already started, but it's not yet finished. Here, the sample is received and it's waiting for it to be filed for analysis, and so on. So I see all that in real time, which is really nice. But let's get started by submitting a sample analysis. So for this, I have created a form that you can fill out. And again, this can be triggered through a REST API, through an event system like Kafka, for instance. You can also file that as an event. And as mentioned before, if it's a new patient you never had used before, you can fill in all the necessary data, or we can also select a patient from the past, and then obviously all the data is already there. Or I might be able to make some correction if the address changed or whatsoever. And then I can select the analysis. So let's say I want to have a PSA analysis, and I immediately see from my master data, I see what material I would have to file in. Or here, I use another one, EDTA, which is a different type of sample that you have to deliver for the analysis. I could also add some notes, but I'm not going to do that. And then I can pre-submit the information, which actually generates QR codes behind the scenes. And if I submit the sample, by the way, I see what we actually do behind the scenes. We start a new case that is tracking all the different parts of when I do need to do some analysis, pre-processing, whatever. It all looks that information up in my analysis master data to check who has to do what to finally and do the final analysis. And of course, we are covering all the SLAs behind the scenes. I will come to that in a minute. Now, we have pre-recorded that information, and it tells us even what material do we need, what we need to prepare to actually file the blood sample or whatever it is. And just to quickly show you how that could look like, that's one of a typical sample, of course, an empty one, and it has those QR codes already attached. Which means when we get it into our laboratory, we can scan that QR code and we know exactly already, oh, that's from this patient, and that's exactly the analysis we need to do with that sample. So to simulate that, of course, I don't have a QR scanner here, but to simulate that, we are using the event system from Flowable. So I can then now choose my latest sample that I just pre-recorded, and I say, I want to send that event that I received the sample. So that came in and I scanned the QR code. That leads to an event that goes into Flowable, and we know exactly which sample case it is addressing, and we can basically kick off that SLA behind the scenes. So, of course, for my demo, I didn't want to wait for 4 hours, right? So I basically have a completion time of 2 minutes and a reaction time of 1 minute. So if I fire sample received, that's actually where the timing starts. So I say, okay, I received that sample, I'm firing off that event, kind of like scanning the QR code. That is registered in the system, and we know, okay, we received that sample. So if I now open the case, you can see we are on a different level, like, hey, I need to prepare the sample, because that type of analysis that I need to do has assigned it to, we need some manual pre-processing before we can do the actual analysis. Now, let me not do it right now and see how that works behind the scenes. And by the way, we already received a notification message like, oh, there's a new sample coming in. So that was part of the initialization of my SLA model that posted a notification. There's a new sample that needs to be worked on. Now, behind the scenes, we still keep track of all the information. As you can see here, now a new message arrived like, hey, please hurry up. Take up the work, because otherwise you're going to miss the SLA. So let's go back to our, and of course it's already yellow. I passed the 1 minute, but let's make sure that we don't miss the other one. So I'm starting, did the preparation, and now I can basically fire the second event that basically picks up the analysis. Now we can do the sample analysis. Of course, I'm not going to do that. We can report the results, or they might even be reported by the machine directly into that case, by the way. And then once done, my case is done, and I didn't miss that final deadline. So I'm still okay there. Now, if I go back to my portal as the customer, they it's already closed. They even see the result immediately. I could also send it by email, which is a PDF or whatever it is. So I'm not going into all the details that Flowable provides by digitalizing those end-to-end processes, but I wanted to focus on the SLA. Now, we have a lot of data coming in. We have a lot of samples. We have a big laboratory that we have to manage. Now, how can I get the overview of what's going on behind the scenes? And that's where analytics come in. So let's dive into the new analytics feature that will also be shipped by the December release later this year. I want to create a new dashboard. So let's say I want to edit the dashboard. And the cool thing is you can do that in real time in the runtime area. So for the dashboards, we thought like, let's be as close to the data as possible. So the first approach is you can directly create dashboards in Flowable Work at runtime, and then basically export it, share it, or even package it in Flowable Design within an app to be deployed the same way like a page you can do today. Now, dashboards are basically created out of components, dashboard components. There's a new, such a component is a new element that we pre-create. So there will be a bunch of dashboard components, but you can also create your own. They are based on queries that actually query data, filter data, aggregate data. So whatever you need in your dashboard, you can get prepared. So let's see our full catalog of dashboards and work with the SLA. So first, maybe I want to get a full overview. So I say I have an overview with all my SLA models, just a full overview. And then I can say, yeah, I want to add that here. I want to get another one. Remember, I had two models, the 4-hour model. So SLA overview for our SLA. I can add a component. I can basically drag and drop it wherever I want. I can use the overview of my model here, SLA overview 1. I can drag and drop it here. And basically, that's how you're going to build your dashboard. And then I can save it, and you basically have all that information. Now, to save some time, I prepared my full-fledged SLA dashboard with a year-to-date metric, which means everything which is up to from January to November, I have in my system that I can look at. So I have my 2-day SLA, which is at a lower scale, as you can see, as my 4-hour SLA. And I see maybe here somewhere in September, I did pretty bad. So I had a lot of breaching SLA. So the yellow one is if we breached the analysis start, and the red ones are actually full SLA breaches if we didn't finish the analysis in time. And you can see the summary of those are basically the overall SLAs. How did we do? So we see, for instance, we were 92.68% within SLA, and we had some breaches like the 0.67% of all my cases were breaching the SLA. And then we can even look at the time deviation for completion time. Let's say for the 4-hour SLA, we can see that's 4 hours, right? So we see in 4 hours, a lot of time we have been advanced, but we also had some breaches, right? And we see the more we go into more and more breaches, the less of such samples we have. So those are predefined SLA-related dashboard components that I can use. But of course, you can also build your own, and you can then basically define queries. By the way, that's also something which is new in Flowable design. So if we say query, I can use a query model. Best query and create a query model. So that the custom one, that's the one you already know. If you're a Flowable user, you can create queries totally custom. You can go crazy there. But we have built a full new query builder, which is way easier to create queries. So you can say, I want to query against cases or processes, tasks, or just any type of work item. And then you can say, I want to add a rule and say, for instance, I only want cases. Well, I only deployed one app. So for my sample analysis, and I want for instance, the end time is before today, and things like that. So you can create your query, and you can say if you're allowing paging, what fields you want. You can even aggregate to aggregation, so you can build charts that we just saw before. So the basics of analytics is queries that create the data set, and then those charts that you can use to build your dashboards. And of course, there's a couple of predefined ones that you can use to build your dashboards, filter them, parameterize them, and build your dashboards as you need them. And the cool thing is they're all real time. Whenever there's a new data point coming in, it is immediately visible in those dashboards. All right, so let's go back to the presentation. So that was basically what I wanted to show for the Flowable SLA model. feature and how that runs or behaves at runtime, how you can define escalation steps, initialization of those SLA work that gets initialized, and how that works at runtime. And also giving a quick introduction into analytics, query building, aggregations, how basically data works to be presented in dashboards, in live and real-time dashboards. All right. I'm at the end of my session, and I wanted to give you some time for questions, if we have any questions, to provide some answers.
Thank you actually for the talk, and we have a lot of questions. Probably we are not going to be able to answer all of them since we just have 5 minutes left.
Yeah.
But let's get started. Can we make SLAs tenant specific?
Yes, of course. All the models, all the apps that you have are tenant aware. So it's the same for SLA. So you can create those SLA models and deploy them to your tenant, and they will only be available within that tenant. Yes.
Okay, that's perfect. Then we already have the first question. Now, the next one is actually, would the escalation be using groups or users? How many SLA models can a tenant hold?
Well, there's no limit, at least, or maybe a technical limit, but from Flowable, there is no limit. So you can create as many SLA models as you want. There's no limitation for that. Maybe your database, if you have millions of those, which you probably don't want, but there's no limitation.
Yeah. I mean, the database is always relevant when it's about performance. So yeah. That makes sense. Then the next question is, does Flowable provide a mechanism for reassigning work based on a user's current workload?
Yes. We also want to provide some models or some kind of mechanisms to do that more elegantly. Nowadays, there's still a bit of not manual work in a sense from runtime, but from a developing time. You can basically come up and create whatever reassignment rule you want for, typical things like people being on vacation, new joiners, movers, leavers, those kind of use cases. But we want to also support them in a new way within Flowable Design, so you can actually create those type of reassignment models, or even initial. We call them routing models. How do you want to route your workload towards your workforce, actually? But that's not planned for the upcoming December release. Most likely will be one of the follow-up releases that we will go into more of that.
That makes sense. Now it's going into the direction of Power BI, actually. And I know from some customers that they integrated Power BI and Flowable. So the specific question actually is, can we use Power BI dashboards in Flowable?
Well, that first of all means that we are able to feed data from Flowable into Power BI, which is actually possible. You can make use of the very same mechanism that we use ourselves to put data from the relational real-time database into the data store, typically Elasticsearch or OpenSearch. You can make use of the very same eventual consistent mechanism to do that. And once you have that data in Power BI, of course, you can create whatever dashboard you want by all the features Power BI has. We will probably never cover such a big thing like Power BI anyway, right? And then you could then basically embed such a dashboard back into Flowable, so you keep your users into one area, into one place, and that will be possible as well.
That's cool. I think we are running out now of time since the session is basically over now. With that, thank you very much, Micha. Thank you, everybody, actually, for watching. And in case you are interested, I think, in the dashboards, it's also good to just stay on that stream, since there is next coming up actually from Joram and Philip, Data as a First-Class Citizen, which is going to tell you more about dashboards.
Great. Thank you very much for listening and watching.